What's up, you freaking geniuses? So in this video, I'm going to give you an introduction into geometric sequences and also teach you how to write them as functions, all right? So as you can see here, I have three lists of numbers, all right? Let's just start with this first one right here. Now, a geometric sequence is just a list of numbers that has a specific pattern or order to it, okay? So here it's kind of easy to identify, right? So to go from 1 to 2, you just double it, right? To go from 2 to 4, you double it. Go from 4 to 8, double it, right? So a more proper way of just saying doubling is we can multiply by 2, right? It's doubling. So to go from 1 to 2, you just multiply by 2. To go from 2 to 4, you multiply by 2. To go from 4 to 8, you multiply by 2, right? 8 to 16 and 16 to 32, same thing, right? So if you wanted to find the rest of the numbers, you would just keep multiplying by 2 to find those numbers, okay? So this is what's known as a geometric sequence, because to go from one number to the next, you're always multiplying by the same number, okay? We're always multiplying by 2, right? And this number that we're always multiplying by, this is called your common ratio, okay? Let's write that right here. So your common ratio is just the number that you keep multiplying by. So in this case, the common ratio, r, would be equal to 2. Okay, now another way that you can find the common ratio is you can say that the ratio is equal to a of 2 divided by a of 1, okay? So this just means that the ratio is equal to the second number in the list or the sequence divided by the first number in the list, okay? So then here, the second number is 2, right? And then we just divide it by the first number, 1. What's 2 divided by 1? That's equal to 2, right? So this is another way that you can find the ratio of a geometric sequence. Okay, so if the ratio is pretty easy to kind of figure out what it is just by looking at it, so like this first one, it's probably fine to just write it like this, but if it's a little bit more complicated, you can definitely use this little equation. And also, you don't have to use necessarily just the first two numbers. You can use any numbers, really, just as long as you take one of these numbers and then divide it by the previous one. Okay, so here I can just say that the ratio is equal to 32 divided by whatever's numbers before it, 16, right? What's 32 divided by 16? Well, that's equal to 2 also, right? And I can do it with any numbers, right? I could pick this one, 8, right? So I can say the ratio is equal to 8 divided by just the number before it, 4, right? 8 divided by 4 is equal to 2. So as long as you just pick any number and then just divide it by the one before it, you're gonna be just fine, all right? Now let's look at this second list right here. So this one is basically just in reverse order of this first one, right? So 32, 16, 8, 4, 2, and 1, right? So all of these are getting cut in half as we go, right? Or another way we could say that is that we're dividing each one by 2, right? 32 divided by 2 is equal to 16, right? 16 divided by 2 is equal to 8. Now, whenever we're talking about geometric sequences, we always want to multiply, okay? So instead of dividing by 2, another thing we could say is we can just multiply by a half, right? 32 times a half is equal to 16, right? 16 times 1/2 is equal to 8, right? So then in this case, our ratio, right? The ratio would be equal to 1/2 or 0.5, whichever way you want to write it. Okay, or again, you could just take one number and divide it by the previous one, right? So I could just say that the ratio is equal to 1 divided by the previous one, which is 2, right? 1 divided by 2 is just 1/2, right? Or again, 0.5, right? So you get the same thing either way. All right, let's clean all that up. Now, one little tip I want to give you with, well, when you're dividing, right? So here, originally I said, oh, we're dividing by 2, but that's the same thing as multiplying by 1/2, right? But let's just say for these numbers, let's say we were dividing each one by 5, right? Divide by 5, right? Divide by 5, okay? Now, this would be the exact same thing as multiplying by 1/5, okay? In order to convert from division to multiplication, right? So if you're dividing by a number, so again, if we were dividing by 2, that's the same thing as multiplying by 1/2, right? If you're dividing by 5, that's the same thing as multiplying by 1/5. If you're dividing by, whatever, 27, that's the same thing as multiplying by 1/27. Okay, so since we have to keep our sequences in multiplication, this is an easy way to convert from division to multiplication, okay? Because sometimes it's easier to see the division part, right? Because 32 to 16, you're like, oh, I'm just cutting it in half, right? That's the same thing as dividing by 2. But remember, can't use division, right? So then we would just say, okay, well, I can convert that, right? It would be the same thing as multiplying by 1/2. All right, so we're going to do a couple examples where this is going to be very useful because you'll probably run across it too, okay? And now the last list I want to go over here is just this one right here. So here we have 1, 3, 5, 7, 9, 11, okay? Now to go from one number to the next, you might notice we're not actually multiplying by anything here, right? Because to go from 1 to 3, you add 2, right? To go from 3 to 5, you add 2, right? 5 to 7, add 2, right? So we're just adding 2 over and over again down this list. So this is not a geometric sequence. This is an arithmetic sequence. Okay, so just make sure you don't confuse the two, because geometric sequences, you're always multiplying, okay? And with an arithmetic sequence, you're adding. All right, so let's do a couple examples. And right here it says find the common ratio and the next term, right? So let's go over this problem right here first. So it says, so we have 36, 6, 1, and 1/6, okay? Now, maybe the ratio is not as obvious with this one, right? So again, we could just pop it into our little equation. Just the ratio is equal to the second number divided by the first number, right? It doesn't necessarily have to be in that order, but in this case, let's just use the first two numbers, all right? So we're gonna say the second number divided by the first number, okay? So we're gonna say the second number divided by the first number. Now 6 divided by 36, that's equal to 1/6, right? So then here, for this sequence, our ratio is equal to 1/6, all right? What does that mean? That means to get from 36 to 6, we're multiplying by 1/6. To get from 6 to 1, we're multiplying by 1/6, right? To get to 1 to 1/6, we're multiplying by a 6, all right? So to get from 1/6 to the next term, we have to multiply by 1/6, right? Well, what is 1/6 times 1/6? Well, let's see. 1/6 times 1/6. Multiplying fractions, right? Just multiply straight across. So we're gonna have 1/36, right? That's your next term that goes right here, all right? So not too bad, right? Let's do this one right here. So here we have -162, 54, -18, and 6, right? So again, the ratio is not super obvious, so I can just take my first two numbers, right? 54 and -162. Now, these numbers are pretty big, so I'm not gonna actually use those, but remember, we can use just any numbers. So let's use these smaller ones, because that's a little bit easier, that maybe we could use these and do it in our head, right? So we're gonna say that the ratio is equal to the first number, right? So 6 divided by the one that's previous to it, right? -18. Okay, this we could definitely do in our head, right? So 6 divided by 18, that's equal to 1/3, right? And a positive divided by a negative is a negative. Okay, so our ratio is equal to -1/3, or -1/3, okay? So again, that just means to get from one number to the next one, we're multiplying by -1/3, okay? We're multiplying by -1/3, okay? So to find the next term over here, we're going to multiply by -1/3. All right, so what is 6 times -1/3? Well, let's do that right here. 6 times -1/3 is, well, we have a whole number times a fraction, but you could turn this into a fraction if that helps. So 6 is the same thing as 6/1, right? So now again, I'm just multiplying two fractions, right, straight across. So on top we have 6 times 1, which is 6. And on the bottom we have 1 times 3, which is 3. And then a positive fraction times a negative fraction is a negative fraction, right? So 6/3, that's equal to 2, right? So here, this is equal to -2, all right? So then the next term right here would be -2, boom. All right, here's the last couple examples. So this one says, write the nth term function and find the 10th term. All right, so whenever you have a sequence like this and you wanna find a number that's way down the line, that's when you wanna use this formula right here, okay? Because this is basically just a little shortcut to find, so for example, in this problem saying find the 10th term, right? So we can use this formula to find the 10th term of this one instead of just listing out all the terms until we get to the 10th term down here, okay? And that's really helpful because what if it asks for the 50th term or the 100th term, right? So then again, we still wanna use this formula right here. Okay, so the first part just says write the nth term function, right? So we're gonna write the nth term function for this sequence first. So first of all, what do these variables stand for? So first, a to the n just tells you what number you're looking for. So here we're looking for the 10th term, right? So that would be what goes here. And then that's gonna be equal to a of 1. And a of 1 is just your first term in your sequence. So that'd be a 2 in this case. And then r is just the ratio that we've been solving this whole time. And then n minus 1. So this n, again, is just gonna be the term that you're looking for, okay? So first of all, if we're writing the function for this sequence, the only two numbers we have to fill out are the first term, the a of 1, and the ratio r, okay? So then we're gonna write this as a of n is equal to the first term, which is a 2, right? So we're gonna say 2, and then times the ratio. Now, what's the ratio here? Well, looks like we're multiplying by 4, but let's say I didn't tell you that, and we wanted to figure it out. We could just say that the ratio is equal to the second term divided by the first term, right? So we just say 8 divided by 2. 8 divided by 2 is equal to 4. Okay, so the ratio here is equal to 4. So we're going to plug in a 4 right there, and then we're going to say that's raised to the n minus 1. Okay, so this is the only information we need to fill out for our function. Okay, so that's the function right there. Now let's say we wanted to actually use this function to find one of the numbers down the list. Well, we can do that, right? So we're going to try and find the 10th term. Okay, so since we're trying to find the 10th term, we're going to plug in a 10 for n right there and right there. Okay, so then we're going to say a of 10 is equal to, again, 2 times 4 raised to the 10 minus 1. Okay, 10 minus 1 is equal to 9. So then we're going to say that this is equal to 2 times 4 raised to the 9th. Okay, so this exponent right here, it only affects what it's attached to, basically, right? So it only affects what's inside the parentheses right here. So 4 raised to the 9th power, that's equal to 262,144, okay? But we're still multiplying by this 2 out here, right? So we're still multiplying by that 2 out there. So 2 times 262,144, that's equal to 524,288, right? So then this would be the 10th term in this geometric sequence for this first problem right here. All right, let's try one more right here. So here's the second problem. So here we have -1/8, +1/4, -1/2, +1, right? So again, write the nth term function. So again, it's just going to be this formula right here. And for the function, again, we only need to fill out what a of 1 is and the ratio, okay? So first of all, a of 1 is equal to just the first term right here, right? -1/8. Okay, so we can just write that here. A of 1 is equal to -1/8. And then the ratio, again, is the second term divided by the first term, right? But I don't want to use fractions. I have a whole number here. Let's just use this one. So we're going to say this one divided by the previous one, right? So we're going to say 1 divided by -1/2. -1/2. Okay, now here we're dividing by a fraction. There's no way to get away from that in this problem, unfortunately. So one thing I like to do with these is rewrite them as 1 divided by, just using a division symbol, -1/2, okay? Now, one thing I'm going to do here is just convert this 1 to a fraction. So 1 is the same thing as just 1/1, right? Now, why do I want to do that? Well, since I'm dividing by a fraction, I want to keep everything as a fraction. And the reason for that is because then I can apply KFC, right? This stands for keep, flip, change, right? So we're going to keep the first fraction as it is. We're going to flip the second one, and then we're going to change the sign from a division to a multiplication. All right, so that's how you divide fractions. So then this is going to be equal to keeping the first one as it is, right? We're going to flip the second one. So this is going to be -2/1, right? Still negative. And then we're multiplying, okay? So then on top we have 1 times 2, which is 2. And on the bottom we have 1. And remember, positive times a negative is a negative, right? So we get -2/1, which is just equal to -2, right? So our ratio is equal to -2. Okay, so our function is going to be a of n is equal to, now our first term is -1/8, right? So -1/8 times our ratio, which is -2, raised to the n minus 1. Okay, there's our function. Now, we can use this function to find one of the terms, right? And again, we're going to find the 10th term. So we're just going to plug in a 10 for the n's right here. Okay, so we're going to say a of 10 is equal to -1/8 times -2 raised to the 10 minus 1, right? And again, that's equal to 9. Okay, now -2 raised to the 9th power, that's equal to -512, right? And then we're still multiplying by this -8 on the outside, right? So we still have a -1/8 on the outside, okay? And then 1/8 times 512, that's equal to 64. Okay, and then we have a negative times a negative, so this is positive, right? So then the 10th term in this sequence right here would be positive 64. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.